In this question, we have a 0.8 kilogram object attached to one end of a spring, and the system is set in simple harmonic motion, and we can see a graph of the displacement x of the object as a function of time. With using this graph, we want to find first the amplitude of the motion, the angular frequency omega, and the spring constant k, the speed of the object at t equals 1 second, and the magnitude of the object's acceleration at t equals 1 second as well. So the first part is straightforward. We can see that the amplitude A of the motion is basically the maximum displacement, and we can read this from the graph here. It's equal to 0.08 meters. In part B, the angular frequency omega, remember that omega is related to the frequency by 2 pi f. Now, from this graph, we can find basically the period, which is the time for a full oscillation. So let's write omega in terms of this period. And from the graph, we can find that the period is 4 seconds. So this is 2 pi over 4. And this will give us a value of 1.6 radians per second for the angular frequency. In part C, we want the spring constant K. Now, we know that the angular frequency that we just found is equal to radical K over m for a spring. And we do have the mass. We have just found omega, so we can rearrange this equation to find K. It will be m omega squared. M is 0.8, and omega we just found it to be 1.6. So this is 1.6 squared, and the final answer will be 2 newtons per meter. In part D, we want the speed at t equals 1 second. So if we look at the graph, at t equals 1 second, we can see that this corresponds to the maximum displacement. And at this special case of maximum displacement, we know that the speed is 0. So at t equal 1 second, we have a maximum displacement so the speed must be 0. In part E, we want the acceleration. Now, we know that the acceleration depends on the force depends on the displacement. If we have a maximum displacement, this means we have a maximum force and then a maximum acceleration corresponding to it. So at t equals 1 second, we have a maximum displacement, like we said, which corresponds to a maximum acceleration. And we know that the maximum acceleration has a formula. A maximum is equal to the amplitude of the displacement times omega squared. We just found the maximum displacement in part A, 0.08, and we found omega, which is 1.6. This is squared, and we will get 0.2 meters per second squared.